Hello, welcome to Pragene Technologies. I am Venkat. This is part 53, Reflection. In this session, we will learn the basics of reflection and also understand the practical use of reflection. Now, what is reflection? Reflection is basically the ability of inspecting an assembly's metadata at runtime. Let's understand what we mean by this. What do we mean by inspecting an assembly's metadata at runtime? Now, understand that whenever you develop any application, for example, if you look at this is a simple console application. And this console application consists of a main class and a customer class. Now, when we build this solution, what's going to happen is these two classes, the customer class and main class, these are compiled into intermediate language and packaged into something called an assembly. And when you look at an assembly consists of two parts. One is the intermediate language and the other one is the metadata. And what does this metadata contain? It contains the information about the types within that assembly. For example, what is the name, what are the different types here within this assembly, main class and customer class. And if you take customer class, what does it have in it? What are the members of this customer class? If you look at that, it has got two public properties, one one constructor and two methods, actually two constructors. One constructor which doesn't take parameters, the other one which takes two parameters. So if you look at this, these are the members of this class. So all this information about these types is actually packaged into that assembly in the form of metadata. Now, what is reflection? Reflection is actually, taking that assembly and then inspecting that assembly to find out, okay, how many classes has this assembly got, and how many enums or structures has this assembly got, and for each class, what are the different members that each class or enum or structure has got. Okay, so doing this, inspecting an assembly's contents by looking at its metadata at runtime is nothing but, you know, reflection. Okay, and how is this reflection useful? This reflection is actually used in several ways. One of the practical examples is here. If you open up a Windows application, let's say Windows application or an ASP.NET web application, when we drag and drop a button, we know that a button is nothing but a class. Okay, if you look at this button control here, this is nothing but a class. Now, when I double click that, we have the button click event handler here. And if I get into the initialize component method here, which is auto generated, you have that button class. And if you look at this button class, it is defined in system.windows.forms namespace. And if you right click on that and say go to definition, and if you look at this button class is inheriting from something called button base. So when I right click on that, go to definition, look at that, this button base has several properties defined. So obviously when we compile this, when Microsoft people who developed this button and button based controls, when they compiled this, all this information about the properties, methods, etc., is also compiled into the assembly in the form of metadata. And now when we drag and drop this button, and when I right click on that, go to properties window, look at the properties window, all these properties are now dynamically displayed here. And how is that possible? We are using reflection here. Now we use reflection, inspect the assembly which contains this class, find out what its properties are, pull out that information and display them here. And you are also able to change these values. Okay, so for example, reflection is extensively used by IDE designers and UI developers. So if you look at this, when you drag and drop a button on a WinForms or an ASP.NET application, the properties window uses reflection to show all the properties of the button class. So reflection is extensively used by IDE or UI designers. IDE stands for Integrated Development Environment, which is nothing but Visual Studio is an example for one of the IDEs. All right. Another practical use of reflection is late binding. Don't worry about late binding. We'll be talking about, late binding with an example in a later session. But however, we'll understand what late binding is here. Now look at this. For example, if you take this example here, we have a customer class. Forget about what this class is doing, but we have a customer class. Now, if I want to create an instance of this class, I will say customer C1 is equal to new customer. So what are we doing here? We are creating an instance of this customer class, but at compile time itself, I know, I have knowledge about this customer class. So at compile time, you're able to create an instance of this customer class. So this is called as early binding. But on the other hand, there might be situations where at compile time, you might not have the knowledge of the class, for which you have to create an instance. Okay, so you can only do that at a runtime, maybe because you don't have the assembly available to you until at runtime. Okay, or for some other reason you don't have any knowledge at compile time about the class for which you are going to create an instance. So at that point of time, you have to create an instance of that class at runtime dynamically. And when you do that, you are actually doing late binding. And one of the ways to achieve late binding is using reflection. At runtime, you check an assembly, you load an assembly dynamically, and then you check that assembly. Okay, the class that I'm looking for, is that existing in that assembly? If yes, create an instance of that class, and then if you want to invoke some methods on that, you will then invoke a method. And a practical example of that, we'll look at it in a later session. But for now, understand that late binding is nothing but creating an instance of a class at runtime rather than at compile time. So late binding can be achieved by using reflection. You can use reflection to dynamically create an instance of a type about which we don't have any information at compile time. So reflection enables us to use code that is not available at compile time. Because look at this here in this example, this customer class, if I have to create an object at early time, at compile time itself, then I need to have this code available at the compile time itself. Otherwise, if this class is not there, if this customer class is not there, and if I try to create a customer C1 is equal to new customer, obviously we will get a compiler error. So if you want to do early binding, you should have knowledge about that class at compile time itself. But whereas you know, when you do late binding, you don't need to have information or knowledge about that class for which you are creating an instance at runtime. All right. So reflection basically enables us to use code that is not available at compile time. Okay, another example of reflection, this third example, actually this is another variation of late binding, but this is more to do with interfaces. Let's say we have one interface and there are two or three providers implementing that interface. Okay, now what we want to do is we want to give the flexibility to the end user, depending, now the developer has three opportunities, three implementations of the interface. Okay, now we want to give the user the flexibility of choosing which implementation they want. And maybe they will just use a simple config file. They specify here, okay, I want this implementation. Okay, they will specify the name of that implementation, that config file, and then our program should read from that config file, and depending on the name that the user has provided there, we have to load that type from the assembly and instantiate that. Again, to do that, we use basically reflection. All right, so we will talk about the second and third examples practically in a later session. But for now, let's see how to inspect an assembly's contents and use reflection framework provided by .NET Framework to inspect that assembly's methods, properties, constructors, etc. Let's look at an example which will make that very clear. All right, now if you look at this example, all we have until now is a customer class, and if you look at that customer class, it has got two auto implemented properties, two constructors, and two methods. One method which prints the ID, the other one prints the name. Now what I want you to basically do is I want you to write a simple function which can list the customer classes, properties, fields, constructors, methods, etc. And how do we do that? That's when we use reflection. And remember, reflection has got a specific class, system.type class. This is very, very important because most of the stuff that we do with reflection is centered around this class, type class, and the type class is present in the system namespace. So the fully qualified name of that is type. So this is very important. Type T is equal to type dot get type. We'll understand what we mean by this in just a minute. So if you look at this here, this method is taking in the name of the type. Now if you look at it, what is the name of our class? Customer class. And within which namespace is this present? Prajim namespace. So we need to pass in the fully qualified name of this type, because if you look at that get type method, what is it expecting? It is expecting the type name. Okay, the fully qualified type name including the namespace name. So prajim.customer. Now when we pass in this here, now what's going to happen is this method get type, the static method on this type class, this is going to get the type of this class, and this type class, this type class provides us with several methods which we can then use to find the information about the methods, constructors, properties, fields, etc. Okay, let's see how to do that first. Now, so T dot, okay, if you look at it, let's say for example, I want to get the information about these properties. I want to list all the properties that are available. So how do I do that? T dot get properties. Look at that. And if you look at the return type of this method, get properties, what is it returning back? It is returning back, look at the IntelliSense. It's returning back an array of property info objects. Okay, so let's get those property info objects. So property info. But if you look at that, you know, Visual Studio shows, okay, I don't have knowledge about this property info. Where is this property info class present? Look at that message there. The type or namespace name property info could not be found. Are you missing a using directive or an assembly reference? Now what we are doing here is reflection. So all the classes, okay, that are part of reflection namespace, I mean reflection framework, are present in system.reflection namespace. So we have to import that. But remember, the type class is present in system namespace, system.reflection. And the moment we do that, the red quickly goes away. Okay, property info. So we got all the properties. Now you might be wondering, okay, how do I know I have to use this property info? It's your IntelliSense. The IntelliSense shows, okay, the return type of get properties is property info. So you know that property infos will contain the information about your properties. Now what you can do, you can use a for each loop through each of the property and print whatever information you want about that property. So for each property, or for each property info, because this is a property info array, let's call property for each property in properties. What we basically want to do, maybe we want to print the name of the property. So this variable here, property dot name. Actually, you can look at this here. There are several property type. Is the property type, look at this, this property type is integer, this property type is string. So if you want the property type, you can make use of that property there, property type. Okay, or if you want just the name, I can just choose just the name. So if I choose just the name, that's it. So we did a simple program using reflection. I got the properties now. So when I run this, you should see there are two properties in our customer class. What are they? ID and name. And if you want the return type of that property as well, the type of the property, you can do that as well. And how do we do that? So property dot property type dot name, and then maybe give a space and then the name of the property. So if we run that, for ID it is integer int32 and name is string. Okay, and similarly, once we got the type, within that type here is nothing but a customer class. Within that customer class we have these two properties, but you can also inspect the information about the type itself. Let's say I want the fully qualified name of this type. It's nothing but prajim.customer, but just to demonstrate that, so t.full name, so maybe console.writeLine, and you want to say full name is equal to, or if you just want the name of the class without the namespace, it's possible as well. And the way you do that is, use the corresponding property. For example, here I just want the name of the class, so we have a property called the name, and if you want the namespace, we have namespace. So just the name, just the name. Similarly, if you want just the namespace, even that's possible. So just the namespace, and we are going to call this namespace. Now if we run this, you should see, okay, full name of the class is equal to Prajim.customer, just the name is customer, just the namespace is Prajim. And then we have the two properties, their return type, and then the names of them. Okay, now if I want to print the properties, okay, it's better actually if you print a heading here, maybe properties in customer class, because we will be printing methods as well. Okay, so far if you see, we have just printed the full name of the customer class, then just the name and the namespace, and then we also have printed the properties with their return types. Let's say I want to print, maybe all the constructors or methods. Let's print the methods first. So if you look at this class, I've got two methods. I want to print both of these methods, and to do that, let's see how we do that. So console.writeLine, we want methods, so we will say methods in customers class. Okay, now to get properties, we used get properties method on the type object. Okay, to get methods, all you do is use get methods method. Okay, so if you look at this get methods method, what is that returning back? It is returning back method info array. Okay, instead of properties info array, this is returning method info array. Now, is it is it required to remember all these return types and other stuff? Not really. You just need to understand the flow of the logic here. To get properties, we are using get properties. To get methods, we use get methods. Similarly, to get fields, we use get fields. To get constructors, we use get constructors. Okay, so it's very meaningful. And all you have to do is hover your mouse over that method, and that method will tell you what is the return type going to be. Here for get methods, it's going to be method info. So instead of property info, I'm going to use method info array, and then give this variable a meaningful name, methods. And then for each method info and method in this methods collection, what we want to do is we want to specify, that a method will have a return type and the name. So I want to find out what is the return type of each method within this class, and then the name of that method. So obviously, to get the method return type, so method dot, there is a property called return type dot name. So I want the return type of the method as well as the name of the method. So method dot name, and just print an empty line here so that there is a space between properties and methods. So now if we run this, look at that, methods in customer class. Actually, it is showing several methods in the customer class. That's interesting. Let's examine. Actually, if you look at this customer class, it has got only two methods, print ID and print name. Let's first see if those methods are there. So print ID and print name, void print ID and void print name, those two are there. But in addition to those, there is something called set name, get name, set ID, get ID. These are nothing but the accessors for these properties. Internally, underneath the scenes, there is a set ID method and a get ID method. Similarly, there is a set name method and a get name method. Even those are treated as methods within this customer class, and that's why they are shown here. Okay, that's fine. So set ID, get name, set name, print ID, print name. Okay, we know what they are and where they are coming from. But if you look at this, there are four other methods. ToString equals get hash code, get type. This is important to understand because every type in .NET actually directly or indirectly inherits from system.object. And if you look at this customer class, look at this. When I create an instance of this customer, customer C1 is equal to new customer. And when you look at C1 dot, look at this. In addition to print name and print ID, I have equals, get hash code, get type, and toString method. So where are these coming from? These are actually coming from the system.object base type. Okay, remember in .NET, every type directly or indirectly inherits from system.object, and system.object has defined these four methods: get type, get hash code, equals, and toString. And all types in .NET will have them. Okay, so these base types which are inherited, I mean these methods which are inherited from the base system.object type, are also shown as methods of this class because they are available within customer class. That's why you see such a big list here. But otherwise our customer class has just two methods, which is print ID and print name. And similarly, if I want the information about constructors, I can do that as well. And the way we do that is, you might have guessed it by now, instead of get properties and get methods, we will use get constructors. And obviously get constructors will return constructors info instead of method info or property info. Let's quickly see how to do that. So just copy paste that code to save some time. Methods in customer class. Instead of that, constructors in customer class. And this is going to be t dot get constructors. And if you look at the return type of get constructors, they return constructors info. So constructor instead of method info, we will say constructor info. And then for each constructor info, let's give this meaningful name, constructors. For each constructor in constructors, what we want to do, we want to print the constructor. But interestingly, if you have the class as customer class, obviously any constructor within the customer class will have the same name as that of your class, because constructors will have the same name as that of your class. So there's no point in printing the name of the customer class, I mean the name of the constructor, because invariably they will have the same name as that of your class. So that's why when you say constructor.name, they don't really give you much information. Let's run this and see what happens. So it says .ctor, constructor, the last four letters of the word in constructor. Okay, so it doesn't, it's not really meaningful. I mean, it's not really useful. I mean, all that you can tell here is this class has got two constructors because the .ctor is printed twice. But that's not really that useful. Instead of that, if you just say constructor dot toString. But what is different, with these constructors is that if you look at this constructor, one constructor takes in two parameters to initialize the class properties, and the other constructor doesn't take any parameters. Okay, now that information is useful, and the .toString method on the constructor object will actually give that information to us. So if you look at that, okay, this customer class has got two constructors, one which takes two parameters and the one which doesn't take any parameters. So obviously this is very simple. Reflection revolves around the system.type. Okay, so if you know much about this type class, you almost know about reflection. Okay, this type class exposes methods like get properties, get methods, get constructors, which return method info, constructor info, property info, object arrays. And similarly, if you want fields, you will say t.get fields. And if you want to know about the method parameters, whatever that method dot get parameters will return you the parameter info objects array. All right. Now, actually, this type, there are several ways to get a type of a class. Here we are using the static type on this type class, static method on this type class. But instead of that, you can also simply use, instead of this line, let's comment that what I basically can do is I can say type, and you can use something called type of keyword. So type of, what is the class that we are interested in? Customer class. So instead of type.getType, you can just say type of. You can use this keyword and get the type of any type. When you use type of keyword, you have to actually pass the class name. Okay, you don't pass it as a string there. So now when I run, the behavior will be exactly similar, except that to get the type of a class, we are using the type of keyword instead of the getType static method on the type class. And there is another way. I mean, at times you might have an instance of a class rather than the class itself. Under such circumstances, you can use the instance, of that class and then use get type on that. For example, let's say I have a customer object like this, customer C1 is equal to new customer, or somebody passes in a customer object to me into my method. And then when that happens, if I want to know the type of that class, all I can do is on that instance, I can call get type method. And if you look at the return type, it again returns type of that object. And remember, all objects, you know, will have the get type method which they inherit from the base system.object class. So when I say type t is equal to that, again here it's the behavior is going to be exactly similar, except that we are using get type on the instance of the class. Okay, so what did we understand in this reflection? Reflection is basically the ability of inspecting an assembly's metadata and runtime. And what are the practical uses of reflection? Reflection is used by IDEs basically to show the object properties when somebody selects them. A classical example is Visual Studio. When you drag and drop a button control either in ASP.NET or a Windows application, you have the properties appearing in the window. How is that possible using reflection? And another major use of reflection is late binding. We will look at an example of late binding in a later session. And to get the type of a specific class or a structure, etc., there are three ways. One is to use the static method on the type class itself, type.getType. When we use the static method, you have to pass in the name of the class, including the namespace, the fully qualified name. The other way is to use the type of keyword. And finally, if you have an instance of the class, on that instance, you can invoke the getType method, which every type in .NET inherits from the base system.object class. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.